Hello, I'm Ken Pier. Behind me is a high-performance programmer's workstation running Cedar. Cedar is an integrated programming environment developed by the Computer Science Lab of the Xerox Palo Alto Research Center. Cedar is used for experimental systems research in many areas of computer science, including graphics and user interfaces. We're going to look at Gargoyle. Gargoyle is a two-dimensional, interactive illustrator implemented in Cedar. Gargoyle uses a new technique called snap-dragging for easily creating geometrically precise drawings. Gargoyle also has features which allow the user to control the appearance of an illustration. Although Gargoyle shares features with both CAD systems and painting system, it's intended for creation and editing of graphic arts quality illustrations. Let's see a short introduction to Gargoyle and learn about snap-dragging.
You are looking at the user interface of the Gargoyle illustration system. A circular cursor moves around on the screen when the mouse is moved. Gargoyle can make other display objects follow the cursor. The upside-down V shape that is now visible is called the caret. Precise positioning operations involve snapping the caret to gravity-active objects in the scene. We begin by placing a stationary object, called the anchor, at the current caret position. The anchor is gravity active, so when the cursor approaches the anchor, the caret jumps to it. Next, we select 30-degree lines in a menu of slope lines. Notice that a line 30 degrees from horizontal appears, passing through the anchor. Likewise, if we select circles of radius 2 inches, then a 2-inch circle appears, centered on the anchor. We can select multiple slope lines and circles at the same time. Now let's construct an equilateral triangle with 2-inch sides and a base at 30 degrees. We add a line segment from the anchor, snapping its endpoint to the intersection of our two alignment objects. We remove the anchor. We make the line segment endpoint hot. This means that the endpoint will trigger alignment objects just as the anchor did. We can make the other endpoint hot as well. Now we can finish the triangle by snapping its third point to the intersection of the two circles. Finally, we close the triangle. Explicitly making points hot can be tedious. If we enable heuristics, Gargoyle will make some endpoints hot automatically. This time, when we draw the triangle, no anchor is needed and no endpoints are made hot explicitly. Just as endpoints can trigger alignment lines and circles, line segments can trigger alignment lines at a specified angle or distance from themselves. Here one segment triggers two alignment lines, each ½ inch from the segment. If we make the whole triangle hot, we can construct a surrounding triangle offset from the first by ½ inch. Line segments can also trigger alignment lines at a specified angle. Here we construct an L shape at an arbitrary orientation using 90-degree alignment lines.
We now show how precise point placement can lead to precise translation, rotation, and scaling. In our example, we first translate a square to a corner of a hexagon. Next, we rotate the square to be collinear with the hexagon's edge, and then scale it to make the two edges congruent. Rotations can align objects that are far apart. Notice that the anchor, the tip of the arrow, and the caret remain collinear during rotation. At the end of the rotation, the arrow points at the center of the circle. Now, let's use dragging and alignment lines together. The left edge of the upper box is made hot. 90-degree slope lines are selected, and the lower box is snapped to the slope line. It is useful to be able to translate parts of objects as well as whole objects. Here we create a slanting letter G using 0 and 60-degree slope lines with heuristics turned on. Now, we select a single segment and drag it along one of the alignment lines. This same technique can be used to make the G shorter. We wish to rotate the G that we have just created until it leans against a vertical wall. We measure the distance from the center of rotation to the point on the G that is going to touch the wall, and we activate alignment circles of that radius. The G will follow the caret along the new circle to its intersection with the wall. We wish to construct the largest square that fits in a hexagon. We turn on 45-degree slope lines, place the caret on a corner of the square, and scale the square until its corner snaps to the hexagon. In summary, snap dragging combines three ideas. First, the caret can be snapped to gravity-active objects and their intersection points. Second, alignment lines may be created and used as temporary gravity-active objects. Finally, interactive transformations follow the caret, as shown here for translation, rotation, scaling, and skewing. Gargoyle can render any shape described in the Xerox Interpress page description language. Shapes include affine transformations of spline curves, text strings, and sampled images. Here, as a text string is skewed, its characters are scan converted on the fly. Now let's watch Steve Walgren, a graphic artist, at work with Gargoyle. He'll make use of some more interesting features of the Illustrator, including appearance control and curve editing. We'll cheat a little and show you the finished picture first. Steve's idea for a poster advertising the park Christmas party is a computer terminal with a keyboard, a mouse, and a screen with a Christmas tree on it, accompanied by a familiar-sounding poem. Steve constructs the illustration in several steps. He begins by designing the top row of keyboard keys. A copy of the top row is dragged into place to form a second offset row of keys. The ends are adjusted flush. The third and fourth rows are similarly constructed. Next, Steve skews the keyboard to give a three-dimensional effect. By copying and modifying the skewed keys, Steve draws a small keypad. He has just aligned the top of the keypad with the top of the existing keyboard. Using slope alignment lines, Steve adds vertical front faces to enhance the three-dimensional effect. Steve finishes the keyboard by adding the Xerox logo to it. He types the word Xerox in the current Gargoyle font. Off to the side is a Cedar text viewer with a list of font names. Steve selects the Xerox logo font and applies it to the new text string. He rotates the text and skews it, snapping the caret to the side of the background rectangle. Finally, he snaps the center of the text to the center of the background rectangle. Using similar techniques, Steve draws a terminal screen and a mouse. He moves the window to the color display and colors them. To color parts of the terminal, Steve selects them and then interactively mixes a color, watching how the color fits in with other parts of the picture. Color mixing is done with a set of color sliders, which are not shown. Steve roughs in the mouse cable as a polygon. Next, he fits an interpolating spline curve to the polygon vertices and makes adjustments to the shape of the spline by moving its control points. When Steve needs finer control, he splices in a new control point by placing the caret on the spline and invoking the Add Control Point command. The new control point can be adjusted as well. Finally, he increases the stroke width of the cable. Steve decides to fill the terminal screen with a raster image of a Christmas tree. This image was made with one of the Cedar three-dimensional modeling systems. Steve scales the raster image to fill the screen, then skews it to match the screen slope. Steve completes the poster with shadow shapes, shading, and the text of the poem. Let's take a look at the user interface that Steve was using. It seems a little overwhelming at first, but it's organized according to some simple rules. Gargoyle has rich functionality and a large number of user operations. Several user interface techniques are used to organize these operations effectively.
A Gargoyle window consists of an upper portion called the control panel and a lower portion called the action area. Mouse and keyboard events directed at the action area may cause new graphical objects to be created, existing graphical objects to be selected, or selected graphical objects to be transformed with an interactive transformation such as dragging, rotating, or scaling. Any action may be aborted by the user before it completes. Gargoyle uses a postfix style of operand operation specification. Graphical objects which are to be modified are first selected. Then an operation is chosen. Operations are organized into groups, and each group appears as a pop-up menu. The user pops up the menu and clicks over the desired operation to invoke it. Gargoyle uses a set of self-documenting buttons called pop-up buttons. Pop-up buttons can be used in two ways. When the user clicks the mouse while holding down some combination of keys, nothing pops up and a particular operation is performed. However, when the user holds down a mouse button, a menu appears. As the user moves the mouse to choose an operation, documentation is displayed. When the mouse button is released, the chosen operation is performed. The menu also indicates the key combinations that can be used to quickly invoke the operation next time. Another style of button used by Gargoyle is the graphics button. A graphics button displays a picture instead of text to indicate the value it represents. Here, the extent of the gravity field is controlled in discrete steps by clicking mouse buttons over the GravExtent graphics button. A picture of the caret in the button moves left as the gravity extent increases and right as it decreases. Operations which have large irreversible effects on the Gargoyle scene are controlled by guarded buttons. Guarded buttons have a line struck through them and require the user to confirm the desired action by clicking twice. Although we have not found it possible to create a completely modeless editor, all modes are displayed at all times. For instance, a button with a black border is used to indicate a binary mode. The user toggles between on and off by clicking the button. Recall that there are 4 types of alignment objects. Each alignment type is managed by a menu of numerical values. Active values are displayed in boldface. Inactive values in plainface. In fact, the alignment menus are formatted for Gargoyle by the Cedar text editor, just like a paragraph of text in a document. When an alignment value is added to or deleted from a menu, reformatting occurs automatically. Textual feedback provides additional information on the current state of an interactive operation. For example, during selection, textual feedback describes the selection as the mouse moves over Gargoyle objects.
Gargoyle is a work in progress. Neither it nor its user interface is in final form. Future experiments will include hierarchies of graphical objects, more elaborate appearance control, graphical searching and substituting, and perhaps freehand input. Users acquire a working knowledge of Gargoyle within a few hours and take a few days to master its intricacies. The Gargoyle illustrations shown here include Celtic knotworks, a Christmas party invitation, a constructed letter, musical symbols, whimsical illustrations, a box and pointer diagram, and several technical illustrations. In fact, Gargoyle is used to include diagrams as comments in its own code.